Hello everyone, welcome to our channel Physics for AP. So in previous video we were discussing about the refraction of light. So we have discussed about the definition. In that we have discussed about the refractive index, that is absolute refractive index and relative refractive index, and we have discussed about which is the denser medium and which is the rarer medium over here, and we have discussed about in which cases that how does the light travels from rarer to denser and from denser to rarer. And in one case that no refraction, that is where we have the no refraction case. So where we have the no refraction case is number one, if the angle of incidence is 0 degrees, then there is no refraction. As yesterday I have shown you the video, when it is falling straight over here like this, when it is perpendicular to the surface and which is making an angle 0 degrees with the normal. So with the normal, then also there is no refraction over here. That means if the light is incident at 0 degrees with the normal, then there is no refraction. And in the second case, two mediums have same refractive index. So that is, as we discussed yesterday about the rarer medium, denser medium, and different mediums have different refractive indexes that we have discussed it over here. So as we discussed yesterday that the water, the refractive index of water, we have 4/3, that is 1.33, and the refractive index of glass we have 3/2, that is 1.5, and the refractive index of air, which is approximately 1.001, which is approximately equals to 1 over here. And if there is the two mediums with two different mediums which are having the same refractive index, like for example we have a medium which has a refractive index of 1.23 and the another medium which is also having a refractive index of 1.23, then also there is no refraction, then in that case the light travels in a straight line. So not only these two, we have another case which will be coming in the next further video, and by this time you need to remember that the no refraction cases is number one, if the angle of incidence is 0 degrees with the normal, then we have no refraction, travels in a straight line. And also if the two mediums are having the same refractive index, then also there is no refraction over here. So next we'll be going to discuss about the Snell's law. So what is the Snell's law, that we will be discussing now in this video over here. So before going about to Snell's law, we'll discuss about the law of refraction. So law of refraction. So what is meant by the law of refraction? As in the very first we have discussed about the reflection, there we have discussed about the law of reflection. At the same case also, here also we will discuss about the law of refraction. That is, the first thing is the incident ray. So the incident ray, the refracted ray, and normal, all these three, that the incident ray, the reflected and normal, lies in a same plane, that is the plane, same surface over here. As yesterday we discussed about this, as you can see, this is the incident ray and this is the normal and this is the refracted ray. So all these three, the incident, the normal, the refracted, all these three are lying in the same surface. So that is what we call it as the same plane. And the second thing, the law of refraction is it obeys Snell's law. So what is meant by Snell's law is n1 sin I is equals to n2 sin R. So the meaning of this is, as the n1, which is called the refractive index of first surface or the first medium, and n2 is the refractive index of the second medium, and here we have the angle of incidence I and we have the angle of refraction R. With this, it obeys the Snells law, that is n1 into the sine ratio of the angle of incidence will be equals to the refractive index of the second medium, that is n2, into the sine ratio of the angle of refraction of here. That is what we call the n1 sin I is equals to n2 sin R. In other case, what we can write it as sin I by sin R is equals to n2 by n1. So n2 by n1 is nothing but the refraction index of second medium with respect to the first medium over here. So we can write the same as ni sin I by sin R is equals to n, which is the refractive index. So for this we have a experiment over here to prove the Snell's law over here, that is sin I by sin R equals to n. To prove the Snell's law, we have an experiment over here, so we'll be doing that experiment. So the aim of the experiment is to prove Snell's law. So to prove Snell's law, what it is, the sin I by sin R is equals to constant. So our aim is to prove that the sin I by sin R equals to constant. So the materials which are required over here, the materials required. So what are the materials required is the A4 sheet, and we need a protractor. So we need a protractor, we need a pencil, we need a scale, we need a semicircular glass slab. So we need a semicircular glass slab, and we need a laser light. So we need a laser light. So what are the materials required is, we need a A4 sheet paper, a protractor, a pencil, scale, and a semicircular glass slab, and also a laser. So what is the procedure of this experiment is, so here we'll take an A4 sheet paper, and in that A4 sheet paper we'll draw the two perpendicular lines, and we mention the total angles, that is starting from here 0 degrees up to here 90 degrees, and again starting from here 0 degrees and from here up to 90 degrees. We'll be measuring the complete angle with the help of a protractor, starting from 0, 10, 20, 10, 20, 30, 40, 50, 60, 70, and so on up to 90. And here also, from starting from 0 degrees, we'll be starting from 10, 20, 30, 40, and we'll be coming in a clockwise direction up to 90 over here. And we'll be start taking the values. So the values will be taken as the mentioned table over here, the serial number, that we take any 2 values, 3 values, or 4 values, and we'll be taking the incident angle, that is the angle of incidence. So let us take the angle of incidence from 30 degrees, 40 degrees, 50 degrees, and 60 degrees sample. Now if you see the upcoming video, so you will be having a video here, and if you place an angle 30 degrees, will be see the sum of the angle will be refracted, that it will be bent towards the normal over here. So we'll mention the angle over here. So practically, if we see, the angle will be as 23 degrees, and the sine ratio of that sine 30 degree, that is the sine angle of the angle of incidence and the sine angle of refraction over here. So sine 23 degrees, and we'll get sin I by sin R ratio, some value we will be getting here. The same value we have to do it for angle 40, then we get the angle of refraction over here, then we get the respective sine angles, sin I, sin R, and same as for angle angle of incidence 50 and angle of incidence for 60, and we get the values, that is sin I by sin R, the constant values we will be getting here. So the values, for example, if we get 1.51, in other case we get 1.52, in another case we will get 1.49, in other case we get 1.50. So the approximate value, if we average them, we get it as 1.5. So if we see all these values which we are getting here are almost equal, and we are getting here as a constant value. So by this experiment we can prove that sin I by sin R is equals to constant, and this constant value is nothing but the refractive index of a glass slab. So what we have taken, the semicircular glass slab. So the refractive index of the semicircular glass, so it is made up of a glass. So 1.5 is the refractive index of the glass which we have taken here. So sin I by sin R equals to constant. By this we can prove that n1 sin I is equals to n2 sin R. So this is what we can prove over here. So also we have a numerical, so we will do one or two numericals based upon this, and before that we will be seeing a video about how we will find how we will do, that is proving the Snell's law with the experiment. We will do it here. So as we said before, so we take a semicircular glass slab which we place it on a A4 sheet paper, and we have drawn the lines, the two perpendicular lines, and we have mentioned the angles from the normal 0 to 90, and here we have a laser light, so as if you see, which is placed at exactly at 0 degrees, so there is no refraction over here. But when we change, you can see the bending of light, as we are at 10 degrees, so it shows nearly 7 degrees of refraction, and we have 15 degrees, the angle of refraction is 10, and we have increased it to 20 degrees, and we can see the angle of refraction as 13, and 25, so it's nearly to 16 degrees or 17, so 30 degrees, so approximately, which is 20 degrees of refraction, 35 degrees, which is nearly to 23 degrees, and 40 degrees, which is 25 degrees of refraction, and 45 degrees of angle of incidence, we get 28 or 29 the angle of refraction, and 50 degrees we get the angle of refraction as 30 or 31, and 55 degrees we get the angle of refraction as 32 or 33, and 60 degrees of angle of incidence, here we get the 35 degrees exactly, which is angle of refraction, and here we have 65, which is nearly 38 of refraction. So this is how we can do the experiment over here with different angles. So we have seen the video, so from that video we'll draw the table like serial number I, angle of incidence, angle of refraction, the sine angle of incidence and the sine angle of refraction, and the ratio of those sine angle which we have here. So practically if we do the experiment, so we get here the constant value. So this constant value is the refractive index of the material which we have taken, that is the semicircular glass slab. So as it is made up of a glass, so we get the refractive index of that glass, that particular glass which we have taken, or any other kind of material which we have taken, the transparent material, so we get the refractive index of that particular transparent material over here. Now let us do a numerical based upon this n1 sin I equals to n2 sin R. So let us do a numerical value over here. So we have a surface, so this is the normal n, and it makes with an angle, as it is incident, it makes an angle of 60 degrees, and we have the refractive index of that particular medium, so air. So as we are making in air, so let's take it as the refractive index as 1, and we have to find out the refractive index of the second medium. So we have to find out the refractive index of the second medium as it bent towards the normal. So it makes an angle of 30 degrees over here. Now we have, so what are the values we have? So we have the refractive index of the first medium, that is 1, and we have the angle of incidence as 60 degrees, and we have the angle of refraction as 30 degrees. And what we have to find out? We have to find out the refractive index of the second medium. So that is the N2, where the refractive index of the second medium we need to find out. So the formula is, we have the N1 sin I is equals to N2 sin R. Now if we substitute N1 into sin I, that is sin 60 degrees, is equals to N2 into sin R, that is sin 30 degrees. So as we need N2 value, so N2 is equals to sin 60 divided by sin 30. So let us find out the values. As sin 60, we have the value as root 3 by 2, by sin 30, we have the value as 1 by 2. So root 3 by 2 into 2 by 1. So when we cancel it and when we do the calculation last, we get the value as N2 is equals to root 3. So root 3 is 1.732. Now the refractive index which we need for the second medium is, that is 1.732. So that is the refractive index of the second medium which we need to find out. So the Snell's law is used to find out the refractive index of the second medium, as well as also we can find out the refractive index, or what are the terms which are not given in the values. So we can find out with the help of this. So that is about the Snell's law, one of the numerical. So let's see another type of a numerical. So let's take another numerical. So given the refractive index as 3 by 2. So 3 by 2 is the given refractive index, and the angle of incidence can be taken as 30 degrees. And we need to find out the angle of refraction, that is R value we have to find out. So how can we find out the angle of refraction? That is with the help of this equation, or we can use this also. So that is, we have the sin I by sin R is equals to N, that is sin 30 degrees by sin R is equals to N value we have as 3 by 2. Now as sin 30 we have 1 by 2, that is 1 by 2 into sin R is equals to 3 by 2. Now if we cross multiply, we get sin R is equals to 2 by 2 into 3. So 2 get cancelled, we get as 1 by 3. So as we need the R value, that is the angle of refraction, so R is equals to, as we have sine value, when it moves on that side we get sine inverse of 1 by 3. Now we got the angle of refraction over here. So the angle of refraction is R is equals to sine inverse 1 by 3. So by seeing the sine table, we can find out the angle. When we apply the sine inverse of 1 by 3, so we get a particular angle over here. So this is how we can find out the angle of refraction, or the refractive index, or any given term which can be used to find out by using the Snell's law formula. So Snell's law formula is N1 sin I equals to N2 sin R, or otherwise sin I by sin R equals to N, or otherwise it can be written as sin I by sin R is equals to N2 by N1, or otherwise it can be written as V1 by V2. So in different cases we can write the sine values, that is sin I by sin R equals to N2 by N1 is equals to V1 by V2 is equals to lambda 1 by lambda 2. So this type of questions may ask in competitive examinations that sin I by sin r equals to dash, we have to fill up it. So it could be n2 by n1 or v1 by v2, or it can be written as lambda 1 by lambda 2 also. So today we have discussed about the Snell's law, the verification of Snell's law. So from that Snell's law we have proved that n1 that is sin I by sin r is equals to constant, and this constant value represents the refractive index of the material. So refractive index of the material which we have taken. Right now, thank you for watching the video. Thank you for watching, and give your valuable comments. I'll be waiting for your valuable comments. Subscribe the channel and give a thumbs up, that is a like. Thank you for watching the video.